Okay, so we're going to finish up Chapter 4 with 4.9. And in 4.9 we talk about quadratic inequalities. We know so far how to graph quadratics. We spent all of Chapter 3 learning how to graph quadratics. And then we learned about solving quadratics in Chapter 4. And that's what we've been doing so far, as we've been solving quadratics. So now we're going to talk about quadratic inequalities, and the only difference really between graphing a quadratic and graphing a quadratic inequality is that there's going to be a shaded region. An inequality is where you have a statement where you have less than or equal to, or greater than or equal to. Usually you'll have a statement, so if it's a quadratic inequality, you'll have one side with y, and then the other side will be in terms of x of x. And so whenever you graph quadratics, remember that they are parabolas. So for quadratic inequalities, you're going to have one side being shaded, or one or the other side being shaded. And so that's what we know about inequalities, and that's what we're going to talk about today. So to graph a quadratic, it has to have the following forms. So it could have the form of y is less than x squared plus bx plus c. Or it could have the form y is less than or equal to x squared plus bx plus c. Or it could have the form y is greater than x squared plus bx plus c, or y is greater than or equal to x squared plus bx plus c. So these are obviously quadratics, but they are inequalities now because of these less than or greater than or equal to signs. That's what makes them inequalities. So how to graph quadratic inequalities? Well, first of all would be to graph it as if it were an equation. So graph quadratic like in equation. So for instance, y is equal to x squared plus bx plus c. And again, we spent all of Chapter 3 doing these exercises of graphing them. So graph it normally as you would. Now, step 2 is to determine whether or not you have a dotted or a dashed line. So dotted dotted or a solid line. Dotted line versus solid line. Now, you'll have a dotted line if your sign, if your inequality is less than or greater than. It will be a solid line if it's less than or equal to or greater than or equal to. So basically, you're going to graph your equation. So you have this being graphed. Now, if your inequality is less than or greater than, then that means you're going to have a dashed or a dotted line. So just go ahead and you would do something like this. You can draw it dashed or you can draw it dotted. Now, if it's greater than or less than or equal to, if it has an equal sign with it, then you just draw it as it normally is. You keep it as a solid line. So that's step 2. And step 3 is to test a region. Test the region and shade accordingly. So, like I said earlier, whenever you're using inequalities with two variables, one one side of the function is going to be shaded and the other is not. And in order to know which one is which, you should test a point in that region. So points will have an xy coordinate, an xy value. So if you pick a point, it will come with an x and a y value. You can then use this x and y value to plug into your inequality and see if you get a true or a false statement. So let's go through an example right here using these steps. So step 1, is to graph. So we're going to graph y is equal to negative x squared minus 2x minus 1. Now this is in a standard form, so you could use x is equal to negative b divided by 2a in order to find the axis of symmetry, and then you could use that to find the max or the min. Now what I'm going to do is I'm going to factor in order to know where the x-intercepts are. So to factor, I'm going to take out a negative, so y is equal to negative, which is going to flip the sign of each of these terms. So it's now positive x squared plus 2x plus 1. Okay. Now I can factor, and I know that this will break down into two binomial factors, and they have to multiply to be 1 and add to be 2, so that has to be x plus 1 and x plus 1. So this is what the factors will consist of. So this is equal to negative x plus 1 squared. Now if I'm going to graph this, here is my y-axis, here is my x-axis. Because it's a duplicate, so x plus 1 is a duplicate, x plus 1, that means my vertex is located right here. And so because now this right here is in vertex form. So I went from standard form to intercept form to vertex form. Okay? And now because it's negative right here, it's going to be facing downward. So here is my quadratic. Just like that. So that was step 1 completed. Now step 2, is it going to be dotted or dashed? Or dashed, I guess I should say solid or dashed. Well, the inequality is less than with no equal sign, which means this is going to be a dashed line. So I'm going to go back and edit this, and I'm going to make my quadratic a dashed line. There we go. So now I know just by looking at the graph that I have that it's less than or equal to. Less than, not equal to, sorry. Now step 3 is to test a point in shaded region. So, just as a tip, for testing, if the point 0, 0, or the origin, is not on the function line, use this point. It's the easiest test point that you could possibly have. Now, if you do have a function, and let's say for example the vertex is the origin, then I would use a point on the y-axis. But yeah, that's just another tip. So first point you should use is 0, 0. And if that's not available, then I would use a point on the y-axis. So something like 0, 1 or 0, 2 or 0, 3, something like that. So in this case, 0, 0, the origin, is not on the line. So I'm going to test this point right here. And if it gives me a false statement in my inequality, then I won't shade there. If it gives me a true statement, then I will shade there. So let's test the point 0, 0. So again, this is an x and y coordinate. So in my inequality, for y is less than negative x squared minus 2x minus 1, I'm going to replace x and y with 0. So 0 is less than negative 0 squared minus 2 times by 0 minus 1. So this is still 0. That's 0, so that goes away. That's 0, so that doesn't matter. And I'm just left with negative 1. So here's a statement. 0 is less than negative 1. Is that true or false? Is 0 less than negative 1? If you think about on a number line, you have 0 and negative 1 is to the left of it. So 0 is actually greater than negative 1, so this is a false statement. So right here, this region outside of the parabola is false. I got a false result, which means I'm not going to shade in that region. I'm going to shade in this region right here. Now if we wanted, we could double check. We could take a point in this region and test it out, but we will get a true statement if we do it correctly. And that is what graphing an inequality is like. Now let's try an example, one more example here. So y is greater than x squared minus 6x plus 8. So step 1 is to graph. So we're going to graph y is equal to x squared minus 6x plus 8. So I'm going to factor this again. So I know that this will equal two binomial factors, and they have to multiply to be 8 and add to be negative 6. So if they multiply to be 8, that means it has to have factors of, say, 4 and 2. But then if they add to be negative 6, it has to be minus 4 and positive 2. So these are my factors, which means they are my x-intercepts. So x minus 4 is equal to 0, and x plus 2 is equal to 0. So then x is equal to 4, and x is equal to negative 2. So on this graph we have x-intercepts at x equals 4 and x equals negative 2. Alright, now we know that the axis of symmetry will be directly in between these points, which I think is right there. So this is the axis of symmetry. Okay, now to find the, in order to in order to find where the vertex is, we have to plug in the x value of the axis of symmetry into the function. Sorry, I think yeah, -4, +2. Okay, so let's this should be x equals +1. So if I plug that into my calculator, I'm going to get sorry, I lied. This should be x minus 4, and this should be x minus 2, because I have to get -6. Okay, so x minus 2 is equal to 0, so that means x is equal to 2. Okay, so that no longer means that my x-intercept's right there, and my axis of symmetry isn't there. Okay. So it's still at 4, and it's still at 2. Those are where my x-intercepts are. Okay? And so that means my axis of symmetry is now at x equals 3. So when we plug that into our equation, we should get the y where the vertex is. So let's plug 3 into the equation. So y is equal to 3 squared minus 6 times by 3 plus 8. So this is equal to 9 minus 18 plus 8, which is equal to -9 plus 8, which is equal to -1. So my vertex will be right here. Okay, so if I were to graph this, it should look something like that. Okay, so for step 2, dashed or solid line. So solid or dashed line. And my inequality states that it's greater than, but not equal to, which means it's going to be a dashed line. So I'm going to go back and edit this and dash the line. Okay, so now that my graph is a dashed line, step 3 is to test a point. Remember that if the point 0, 0 is available and not on the line of the function, use that point. So I'm good here. So I'm going to use the point 0, 0 to test that. So for y is greater than x squared minus 6x plus 8, let's plug in 0 for y and 0 for x. Okay, so this is 0 on this side. That's 0, and that's 0. So then I have this right here. So my statement says 0 is greater than 8, which we know is false. So it's false. So the region out here tests false, which means we shade on the other side. So we're going to shade inside the parabola. There you go. There's our inequality. Now, there's a pattern here. So notice here that in this one we also shaded inside the parabola. Okay? This one we shaded inside the parabola. But up here it was less than, here it was greater than. Now the difference between our parabolas is that this parabola is facing downward and this one is facing upward. Now, another way of deciding whether to shade inside or outside the parabola is whether or not the inequality is less than or greater than. So, if less than or equal to, you can shade below the function, below the quadratic. So like up here, this function right here is facing downward. The inequality says less than. So I can shade beneath it. And so this is a way to, instead of testing a point, testing is always good to double check, but it's also a shortcut that since it's less than, I know that I'm going to be shading beneath my graph. Now down here, if the inequality is greater than or equal to, you can shade above the quadratic. So like in this one, my inequality is greater than, and I'm shading above the line. If this said y was less than x squared minus 6x plus 8, then I would have shaded this region right here. And our point would have tested true, our origin point. Okay, now last thing that we're going to do for this section is to solve a quadratic algebraically, a quadratic inequality algebraically. So, here we have another quadratic. Now, we can't graph it, right? We're not talking about graphing it. We're talking about just solving it algebraically. Now, to do this, you want to find the zeros. Find the zeros / x-intercepts. So I know I can do that by factoring. So I could do this one. I can split it up into two binomial factors. And the factors have to multiply to be -4 and add to be -3. So that would have to be -4 plus 1. So these are the factors, which means if the product is equal to 0, that means x minus 4 equals 0, or x plus 1 equals 0. And in this case, x would be equal to 4, or x would be equal to -1. So here I know our x-intercepts. Now what I'm going to do is I'm going to make a number line. And I know that I'll place 0 right here. Now, -1 is right here, and I know that there's going to be an x-intercept at -1. Then I have 1, 2, 3, 4. This is 4. Okay, so these are my x-intercepts. Now, the second step that you want to do, once you have your intercepts, is to use solid or open circles. So use solid if it's equal less than or equal to or greater than or equal to. Use open if less than or greater than. So in this case, it's just less than. So my circles, like you see here, are open, not solid. If they were solid, they would look something like that. So that's just an indicator of whether or not it's less than or equal to, greater than or equal to, less than or greater than. Okay. Now, on this number line, we need to determine whether or not if this is shaded, or this is shaded. So we can use the same idea and test the point. Okay, so always the easiest point to test is this one right here, 0. So we're going to plug that back into our inequality. So we're going to use the point 0, 0. So we have x squared minus 3x minus 4 is less than 0. So we're going to use the point x equals 0 to see if this inequality is true. So we have 0 squared minus 3 times by 0 minus 4 is less than 0. So that goes away and that goes away. So I have negative 4 is less than 0. Okay, so negative 4 is less than 0. Now we know that this is a true statement. So since that is a true statement, we know exactly where we are going to shade on this number line, or we can create intervals and inequalities. So we tested this point right here, and it tested true, so negative 4 was less than 0. So this region right here will be shaded. Now the regions outside will not be shaded. And we could, if we wanted to, test regions outside here. So we could take the point negative 2. And if we take the point negative 2, and if we plug it into our inequality, then we will see that we'll get a false statement. We could also take this point right here, say 5, plug that into our inequality, and we should get a false statement. But we don't really need to at this point. We know where the region's going to be. So basically, algebraically, we know that the x values for which is correct are between negative 1 and 4. So we could write this as an interval or an inequality. So the x values will exist between negative 1 and positive 4. Now, if it's not greater than or equal to, or less than or equal to, then we're going to use parentheses. If this had been less than or equal to, we would have used brackets. Like this, brackets. Okay. And another way to write this, so this is one option of writing it, or we could have written that x had to be less than 4 or greater than negative 1. So that's one way we could have written it. But this is the solution algebraically to the quadratic inequality. Okay, now that should be everything for this video. You should have everything that you need to do the homework and the extra practice problems. So email me if you have any questions. Thanks.